Alright guys, in this video I'm going to go through the 2-point-D basic properties of logarithms DeltaMath assignment and do some examples from each of them. So let's start with condensing logarithms. Alright, so condense the logarithm. So we have 6 times log of A plus log of B. So the first thing we're going to do is anytime I see a constant out front and I want to combine this into one single logarithm, I'm going to go ahead and pull that constant up to be on an exponent inside of my logarithm. So I'll have log of a to the, oops, it's terrible, a to the 6 plus log of b. And then because I have addition between two logarithms, so addition outside of logarithms, it can combine into multiplication inside of one logarithm. So a to the 6 times b. So I'm just going to type that in here. A, and then if I hold shift 6, that pops it up into the exponent. It's actually a 6 and then a b. You can put a multiplication symbol in there too if you want. Voila. Let's do another one. All right, so in this problem, it looks a very similar setup, right? I have a constant multiplying in the front. I'm assuming that g is a constant. I guess we'll find out, won't we? So I see that as log of a to the g power minus log of d. And then when you have subtraction outside of two logarithms, then it turns into division inside of one logarithm. So a to the g divided by d. A to the g divided by d. Yep. All right, let's go ahead and do one more. This one has constants out front of both of my logarithms. So I'm going to move my q up to become an exponent. Same thing with my 3. So it'll be log of b to the q power plus log of k to the 3rd power. And then addition between two logarithms turns into multiplication inside of one logarithm. It's weird to see a q as an exponent. B to the q, k to the 3rd. Perfect. So those are how those ones go. Let's go ahead and go to condensing numerical logarithms. All right, write the expression below as a single logarithm in its simplest form. So, again, I normally see any constants out front of my logarithms. I put those up, and now they are going to become exponents. So this will be log base b of 6 plus log base b of 2 to the 4th power. And it's kind of up to you. You can either do 2 to the 4th here, or I'm actually going to combine it all and then I'm going to simplify. So the addition between or outside of two logarithms turns into multiplication inside of one logarithm. So 6 times 2 to the 4th power. And then in my calculator, I'll just do 6 times 2 to the 4th. 6 times 2 to the 4th, which would give me 96. So log base b of 96. Voila. See, they did it too. They actually calculated 2 to the 4th here and then combined them, but you can kind of do it all at once. All right, let's do another one of these. Wow, didn't want to scribble there, I wanted to erase. All right, for this one, I got 3 log base b of 3, so I'm going to go ahead and move that up to become an exponent. For those of you who are kind of confused about what I mean by move it up, I mean take this 3, oops, and put it up here as an exponent. This only works with logarithms, so if you have a constant multiplying out front of your logarithm, it can go inside of your logarithm as an exponent. So log base b of 3 to the 3rd, and then actually calculating 3 to the 3rd is 27. Voila. All right, so those are how those problems go. And now I'm going to do expanding logarithm, but just with our first level, level 1. All right, For this one, it says, explain the logarithm fully using properties of logs. Express the final answers in terms of log of x and log of y. So the first thing I notice is that I have this is in just one logarithm, right? Even though they're not using parentheses, this is what they mean. They mean that all this stuff is inside of that logarithm. I have multiplication happening, so I'm going to split that up first. So log of x to the fourth, and then multiplication inside of a logarithm turns into addition between two logarithms or outside of the logarithms. All right, and then now I'm going to go ahead and bring those exponents down to be constant multiples in the front. When you're expanding, I leave my exponent stuff until the end. When you're condensing, you would have to do it first, and I'll show you what I mean here in a second. Oops. So if I'm going this way with the problem, my very last step is bringing out exponents. If I was going to start with this and then condense my logarithm, my very first thing would be to move these back up to become exponents. So, all right, let's write out our answer. I think we can just type the word log, L-O-G. Yep, log of x plus 2 L-O-G y. Voila. All right, let's do another one. So in this one, it's a little tricky because I notice that we have its log of 8x squared, and this is actually, this 8 and this x squared are multiplying secretly, right? So multiplication inside of a logarithm turns into addition between two separate logarithms. And then I have an exponent, so I'm going to go ahead and bring that to the front. So then I'll have log of 8 plus 2 log of x. There we go. So that's how you work through those problems for 2.D, basic properties of logarithms.